Hello.
Yes, sir.
Okay. Once again, good afternoon, everyone. Uh, we are discussing solutions of linear differential equation with constant coefficient, which which is in standard form. The linear differential equation in constant coefficient, uh, in its standard form, phi of d into y is equal to function of independent variable on the right hand side. Most of the times it will be x and y, but it is not all the time. So its solution is called the general solution or the complete solution, which is a combination of two sub-solutions, complementary function and particular integral. So we almost have discussed in detail about the complementary function, and now we are discussing about the particular integral, the methods of finding the particular integral. There are three methods. First is general method, that also we have discussed in general, right, in detail. And the second method is shortcut method to find the particular integral that we are discussing. As we all know that the shortcut methods is particularly depends on this right hand side function, what kind of that function is, and accordingly we have the shortcut formula. So we are discussing the sub cases or the shortcut methods. So the first case we have discussed as a exponential. If the right hand side function is exponential, e to the power ax, or a to the power x, or a to the power minus x, or it is a constant. Okay, so for all these we have a simple keyword. What is that? What we are doing in case of exponential function, we are replacing d by a, right? So the particular integral is equals to 1 upon phi of d into e to the power ax will be equals to what? 1 upon phi at a e to the power ax, provided that phi of a must be non-zero. If it is zero, then that is called a case of failure. And in case of failure, what we are doing, we are we are multiplying this operator by independent variable and we are differentiating the denominator. So if this phi of a is zero, that is case of failure, then pi equals to 1 upon phi of d e to the power ax can be written as x into 1 upon phi dash at a e to the power ax, provided that this must be non-zero. If it is again 0, then we again take the derivative of this, and one more time x will be there, that is x into one more x, that is x square into 1 upon phi double dash at a e to the power ax, provided that phi double dash of a is non-zero and phi dash of a is 0, and so on. Clear? So this is about the first shortcut case. We have discussed in detail, even we have discussed the examples also, right? So I hope no one have a doubt related to this. Is there anyone who is having doubt in this first shortcut case? Please let me know if any doubt. Yes, any doubt? Shall we proceed with the next? Okay, so therefore second case is when f of x is trigonometric function sine of ax plus b, or cos of ax plus b, like sine of 2x plus 3, or simply sine ax or cos ax. Most of the times this b term will be having to be 0 most of the times. Okay, so in this case, what will be the particular integral, or how do we get the particular integral by shortcut method? So first of all, let us have a specific pattern, just like the exponential function. How do we have obtained, or how do we have replaced d by a? Because d is nothing but the derivative. We have taken successive derivatives of exponential function, and then we have come across the conclusion that whatever the function of d we are applying over the exponential function, that same kind of function in the variable a we are getting on the right hand side, right? Isn't it? So the similar pattern will be there here. Let's see. For example, what is d of let us discuss the case for sine only. The similar case for cos will be there, isn't it? We'll be discussing only for sine. So what is d of sine x? What is derivative of sine x? Sine ax. Yes, what is the derivative of sine ax?
A cos ax.
Yeah, it is a cos ax. Now, if I take one more derivative, that is d square of sine ax, then that will be derivative of this a cos ax, right? And that is equals to what? Yes, a will be outside.
minus
Derivative of
minus a
cos is
square
minus a sine,
minus a square
sin x
sin x.
yeah, sine ax. So that will be equals to what? Minus of a square sine of ax. Is it? Minus sign will be outside of square. Similarly, if I operate one more d, then that will be d cube of sine ax. So what it will be? Can you guess the pattern? That will be a cube, but suppose this is the derivative
minus a
of
cube cos ax
d square
Cos
sine
ax.
ax, right? That is derivative of minus a square sine ax, and that is equals to minus a square. If I take outside, then that will be into a sine ka derivative cos ax, right? So that is minus a cube cos ax, isn't it? But if you notice the change, that when we take the first derivative, what we observe, the derivative of sine will be in terms of cos, isn't it? For the second derivative, the d square of sine will be in terms of sine, isn't it? For the third derivative, it is in terms of cos again. If we go for the next derivative, what will be d raised to 4? D raised to 4 of sine ax will be what? Yes, it will be
a
a
raised
raised
to 4 sin ax
Sin x.
yes, plus a raised to 4 sine ax. So can we generalize the pattern? Hmm? Can you generalize? Actually, what we want, suppose the right hand side function is given to be in terms of sine, then we want the particular integral in terms of sine only. That should not be in terms of other function like cos or any other. So here I can write this d raised to 4 as a d square square of sine ax, right? And this a raised to 4 can be written as a square square sine ax. Is it? Will it be okay if I give the negative sign here? Will it change? Yes. Can I give you here the negative sign, because minus ka square will be plus only, positive only. That will be getting a raised to 4 only, isn't it? Is this clear to everyone? So
Yes.
how am I writing? I'm writing a raised to 4 in terms of minus a square. Why? Because sometimes I'm getting the plus term, sometimes minus. Is it? So we can say odd powers of d will leads the, no, that is again not possible to get only the positive terms. And even for the even powers also, sometimes some terms are positive, some terms are negative, isn't it? Like d square term is positive, negative, and d raised to 4 term is positive, isn't it? So so here I'm trying to write the relation in general. So here we can generalize it now. If we go for the next derivative, then that will be d raised to 5, again d raised to 6, again d raised to 7, isn't it? So those, all those derivatives, if I try to write in terms of d square, then I'll be getting on the right hand side, I'll be getting the function of minus of a square. You just try, you won't, you'll get the idea what I'm trying to say. So from this I can generalize now that if I operate on the left hand side the function of d square onto sine ax, on the right hand side what I'm getting, I'm getting a function of minus a square. Is this point clear to everyone? So from this I can now write the formula for particular integral by dividing both sides by 1 upon phi of d, and by taking this phi of minus a square to the left hand side, what I'll be getting, 1 upon phi of d square, or you may get confused, 1 upon phi of minus a square sine ax will be equals to 1 upon phi of d square sine ax. Is this point clear? Hello? So from this we get the formula of particular integral, that is, therefore pi equals to 1 upon phi of d f of x. But what is my f of x here? That is what we have considered to be f of x, we have considered to be sine, right? Sine of ax. So that is equals to 1 upon phi at minus a square sine ax. Now here purposely I have written in terms of d because I want to note it down that the given phi of d may be in terms of d, but we have to get that phi of d in terms of d square for the replacement, remember. So here the keyword for the second rule is replace d square by minus times a square. This is very important. Replace d square by minus a square, provided that this phi of minus a square must be non-zero. If it is zero, then that will be a case of failure, and in case of failure, will be same thing we'll be doing. We'll multiply this operator by independent variable, and then we will differentiate this phi with respect to d successively till and until we'll get the non-zero denominator. That is what the exact procedure for the second case. Is this clear to everyone? Second case. Everyone, please do reply in chat box. If you are having any kind of doubt, please ask. Get clear your doubts, if any. Okay. So let us generalize it now. That in case of failure, if phi of minus a square is 0, it is a case of failure. Then pi equals to 1 upon phi of d square sine of ax can be written as x into 1 upon phi dash at minus a square sine of ax, provided that phi dash at minus a square must be non-zero. And so on. And the same thing for cos we are having. So the second formula I'm directly writing now, that 1 upon phi of d square operated on cos ax or cos of ax plus b can be written as 1 upon phi of minus a square cos of ax, provided that phi of minus a square must be non-zero. Okay, remember we are replacing d square by minus times a square, not like this, huh? Not like minus of a and then square. No, this is wrong. What we are doing, we are replacing d square by minus times a square. Is this point clear to everyone, so that we can proceed with the example questions? So can we generalize these two results just like the exponential function? If we have repeated factors in the denominator, then it will be not manually possible to take the derivative all the time, isn't it? So can we generalize it? So of course yes. So I can give the formulas directly. So you can note these formulas. The first formula is, in general, 1 upon d square plus a square raised to r sine of ax, or I can write in terms of ax plus b. Okay, here also you can write in terms of ax plus b, but most of the times that b is 0. Clear? So that can be written as a minus x upon 2a to the power r into 1 upon r factorial sine of ax plus b plus r pi by 2. This is the generalized result. Now you might be thinking that what is the role of this pi by 2? Yes, this is the question from my side. What is the role of this pi by 2? Some extraordinary answer. And the similar rule for cos I'm writing 1 upon d square plus a square raised to r cos of ax plus b can be written as minus x upon 2a raised to r into 1 upon r factorial cos of ax plus b plus r pi by 2. So we can see here, if I replace d square by minus a square, what is a? A is the coefficient of x in the angle, sine of ax plus b. Into that, the coefficient of x is a. So when I replace this d square by minus a square, I'll be getting this case of failure factor. How many times? R times, isn't it? So if this R is very much large, then that is not manually possible to take the successive differentiation just like the above, isn't it? For 1 or 2, it is okay. So these formulas you can used in the competitive examinations. So yes, is there anyone who will tell me the role of this pi by 2?
Differentiate, then there will become cos term and sin term. That's why there is pi by 2.
Right? But what the role of pi by 2 then? You are very near to the answer. Actually, when we differentiate, what will be getting? Suppose if I have r is equal to 1 into the same formula, then what will get? For r is equal to 1, I'll have to differentiate once, no?
Sir, it will be cos. Sir, it will be cos then, sir. But we have to generalize. That's
Huh.
why we are taking pi by 2 into r.
So by taking pi by 2, what exactly we are trying to get? You're right. By adding pi by 2 there
Means
into the angle of
suppose there
sine.
is r is equals to 2.
No, no, for r is equal to 1. We are talking about r is equal to 1. Then for the first derivative, we'll be having the cos on the right hand side, right? Just see here.
Yes, sir.
Here, this one, isn't it? So how do we get this cos in terms of sine? Because we are discussing the case for sine, right? And we want this cos in terms of sine.
Sin of ax
So that
plus
is
pi
why,
by 2
right, exactly. So sine of ax plus pi by 2 is nothing but what? Hmm?
cos
Pi
ax
by 2 plus theta. What is sine pi by 2 plus theta?
Cos theta.
cos theta.
Cos theta.
Theta.
Is this clear? So what we are trying to do, that we are trying to represent these trigonometric expressions, I mean sine in terms of sine only. So using suitable values of or multiples of pi by 2, where we are trying to convert cos in terms of sine or sine in terms of cos. Is this point clear? Hello. So for r is equal to 1, 1 pi by 2. For r is equal to 2, that will be 2 times pi by 2. That is simply pi. So sine of pi plus theta will be sine theta only, isn't it? Hello.
Yes, sir.
And the same thing for cos we can do. So that is why for the generalized case we have used pi by 2 in terms of angle. Don't get confused with the formulas. Why? That should be clear. So this is minus x upon 2a raised to r. So for r positive, or in fact instead of positive we can say, for r to be odd number, we'll be getting negative or minus sign here, and for r to be even, we'll be getting positive sign. Okay. So now mainly this case is for sine and cos only. Like for example, uh, if we are having the differential equations, like solve d square plus 3d plus 1 times y is equal to, say, sine of 2x, sine of 2x. So isn't it? So we can directly use this case for getting to particular integral. But if it is sine of 2x into say cos 3x, then we cannot use directly, isn't it? Or if we have sine square 2x, then also we cannot use directly. So for that purpose, we should have some trigonometric expressions. Is it? We already have used those relations in the lower classes. We should know those. So, to convert those functions in terms of required sine and cos, linear sine and cos, because our case is linear sine and cos. Okay, so we have the formulas. I'm writing those formulas. The first one is sine square. So as we have the case of sine as a linear sine or linear cos only, so how do we get sine square of theta, we can say, or x? How do I write sine square x in terms of linear sine or cos? Do we have any formula in trigonometry?
1 minus cos
Sir,
2x.
cos 2 theta.
Exactly. It is 1 minus,
1 minus
uh,
cos 2x by 2.
right, 1 minus cos 2x by 2. So here cos is linear, sorry, it is 2, no?
2.
Isn't it? So here I can then write it as a 1 by 2 minus cos of 2x by 2, isn't it? So this will be constant, I can treat, and this will be in terms of linear cos, so that I can proceed with the case. Clear? So if it is given to be sine square, then we have to convert it into linear sine and cos. Similarly, we can have the formula for cos square also. What is the formula for cos square? Cos
1
square x
plus
equal to
cos
1 plus cos
2x.
square x. Right, very good. Upon 2. Similarly, if I have the product of two trigonometric expressions like sine A cos B, then what is the formula? Sine A cos B equals to, yes, or we may be having the formula for 2 sine A cos B, right? 2 sine A cos B is equals to what?
Cos a minus b minus cos a plus.
Very good. Cos A minus B minus cos of A
A
plus B.
plus b.
So that this product of sine and cos will get converted into linear cos only, isn't it? So I'm taking this 2 onto the right hand side. So 1 by 2 times the whole. Sorry. Similarly, we can have the formula for cos A cos B. What's that? Cos A cos B also can be converted in terms of this linear. Is it in terms of cos only? Cos of A plus B plus
Yes.
cos of A minus B. Check. And one more formula we can have in terms of sine A sine B, that is half of
Sine a.
I think the first one is of sine A sine B, right?
Ah, yes. Yes, sir.
This one is of sine A sine B.
Minus sine b.
Hmm. And what about here cos sine A cos B?
Sin A plus B plus
It
cos
is
A
only in terms
minus
of
Sine
B.
a
sine, right?
plus b.
No, sine A cos B is in terms of sine only. Sine of A plus B
Yes.
plus sine of A minus B, isn't it? Check these formulas. Okay. Now, okay, I think these are the only formulas by which we can convert higher order sine and cos into linear sine and cos expressions. Now, here, as the case is for the replacing d square by minus a square. So what if the power of d is linear? I mean, suppose the linear factor is there in the phi of d, like 1 upon For example, I'm writing here 1 upon d plus 1, say, okay, sine of x. Then how do I get, because as we know for sine we have to replace d square. So how do we get d square in the denominator? Hmm? See, this case is only for the d square, huh? Not for d.
Yes.
Because
Rationalize.
the students are considering this case as a, since we are replacing d square by minus a square, we have to replace d by square root of this minus a square. No, clear? So we have this case only for the d square. So to get d square in the denominator, we have to rationalize the denominator. Exactly, rationalize it. Okay. By rationalizing, we'll get d square in the denominator and then use the case. So sometimes we can have the expressions like d cube. Then how do I replace d square in this d cube? D cube I can write it as a d into d square. So we have to replace to this d square only, or d raised to 4 I can have. So that will be d square square or d square into d square, and so on. So let us look at the simple question, simple example. I hope there is no doubt in the theory part for the second case. Is there any doubt? You can ask your doubts in between. I'm writing the question. Solve. D square plus 2d plus 1. Very simple basic question. D square plus 2d plus 1 times y equals to 4 sine 2x. So its general solution is what? Y equal to CF plus PI. To find complementary function, what we are doing? We consider homogeneous differential equation. What is that? D square plus 2d plus 1 times y equals to 0. So its auxiliary equation is d square plus 2d plus 1 times, not times, equal to 0. So the roots of auxiliary equations are minus 1, right? Because this is the expansion of d plus 1 the whole square. So the roots are real and distinct, right?
Repeat it.
Good. Real, real and repeated root. So therefore, the complementary function is, how do I write the complementary function? Just a minute. Let me ask to someone. Siddesh Chavan. Siddesh, just unmute yourself.
Yes, sir.
Tell me the complementary function for this. I just want to know whether the complementary function is uh, or whether you are able to write the complementary function or not. Siddesh. Hello.
Hello, sir.
Am I audible, Siddesh? Hello.
Yes, sir.
What is the complementary function? You're not audible. Okay, I'll note this. Siddhant, are you there?
Yes, sir.
Okay, Siddhant, let's say what is a complementary function, Siddhant? I don't know what the problem is. Hello, Siddhant. You're not audible actually.
Sir, he is having some problem, sir.
Okay. Supriya Yadav. Supriya. Hello, Supriya Yadav. Tejas.
Hello, sir. Am I audible? Hello,
Ah, yes.
sir. Answer is C1 plus C2 e raised to minus x.
C1 plus.
C2.
Is it just C2?
Yes. E raised to minus x.
X, sir, X. C2
It
into
must
X.
be X here.
Okay.
Siddhant. Sorry. Yes, Siddhant. It must be X here because if the roots are two times repeated, then we have to write C1 plus C2x. If the roots are three times repeated, then C1 plus C2x plus C3x square into e raised to minus x and so on. So we have to go on increasing powers of x here. Siddhant, is this clear?
Yes, sir.
Okay, thanks, Siddhant. So to find particular integral, pi equals to 1 upon phi of d. I'm writing the formula first of all into the right hand side function. So what is my phi of d here given? It is d square plus 2d plus 1, and f of x is given to be uh, 4 sine 2x, right? So here the case says replace d square by minus a square. What is a here? What is
2.
a? What is a is 2. So replace d square by minus
2.
2 square. Is it? So therefore, particular integral is therefore pi equals to 1 upon minus 4 plus 2d plus 1 times 4 sine 2x. So that is equals to 1 upon 2d minus 3 4 sine 2x. Again, d is there. So what we have to do? We need d square for the replacement. So we do rationalization. So on rationalizing the denominator, what we'll get? 2d plus 3 upon 2d minus 3 into 2d plus 3. 4 sine 2x. So that is equals to 4d square minus 9 4 sine 2x. And therefore, again on replacing d square by minus a square, what I'll be getting? 2d plus 3 upon 4 into minus 4 minus 9 into 4 sine 2x. Here I'm writing on replacing d square by minus 4. That is minus a square. So how much is this now? Minus 16 minus 25 minus 9 minus 25. So minus 4 by 25 I'm writing outside, and then 2d plus 3 operated on sine 2x. Okay. Now let us operate this operator over the function. Minus 4 by 25 into 2d sine 2x plus 3 sine 2x. So that is equals to 2 times, what is derivative of sine 2x? That is 2
2
cos
cos
2x plus 3 sine 2x. You can see here d is completely eliminated, isn't it? Completely get eliminated. So therefore I can now multiply inside minus 16 by 25 cos 2x minus 12 by 25 sine 2x, and that is your final particular integral. Hello, is this clear to everyone? You can ask your doubts if any. So we have to eliminate d completely while getting the complementary, particular integral. Any questions?
Sir, I have a doubt.
Yes, please.
Yeah, sir, we have to only differentiate the d function, like not that plus 3 sine 2x last.
Uh, just a minute. Here,
Yeah, not
here
the
you're
whole
asking.
function, only d function.
See, we are operating this operator over the function. This is
Yeah.
operator. This is not a function. So 2d times sine of 2x means only derivative of sine 2x, no? 2 times derivative of sine 2x. And then 3 operated on, 3 into sine 2x, like this. We have opened this operator over the function. That's it.
Yeah, so we do not have to differentiate that plus 3 sine 2x.
Where that plus 3 sine 2x is there?
2d sine 2x plus 3 sine 2x.
No, actually you are not getting. Just a minute. Just a minute. Let me explain here only. First of all, tell me, is this step clear? Do you have any doubt in this step?
Yes, sir.
Hmm? Okay. So now,
Sir, you are saying like that D stands for ddx, na? That's
yeah,
only that term is
d by
differentiated, na?
dx.
yeah, that is only that one.
Yeah.
So I'm opening this operator over this function. So that is this or this into the function, or and this into the function. That is what I'm doing. Okay, so that is 2d into sine 2x. Why I'm not saying into? Because that is operator. That is why I said 2d operated on sine 2x plus 3 into sine 2x, and then d means, so just d means
Okay,
derivative,
okay.
because if you remember we have started with this d only. This d is nothing but the derivative with respect to independent variable. Clear? So that is why we are differentiating only sine 2x term. Is this point clear?
Yes, sir.
Okay. Anyone else? Okay. Right on next. D square plus 1 times y equal to sin x into sin 2x. Next one. Next question. D square plus 1 times y is equal to sin x into sin of 2x. Yes, what are the roots here then?
Plus minus.
Plus
Plus or
minus
minus I.
I. The roots are plus minus I. Therefore, the complementary function is
C1 cos x plus C2 sin
yes.
x.
Plus minus I means 0 plus minus I. So here alpha is 0 and beta is 1. As we have the formula for complementary roots, that is e to the power alpha x into c1 cos beta x plus c2 sin beta x, right? So alpha is 0 and beta is 1. Okay? So therefore, थोड़ा ये तो 10 मिनट ठीक है लेट ज्वाइन करेंगे. So therefore, for alpha is equal to 0, e raised to 0 is 1. So that will be c1 cos x plus c2 sin x. Clear? So this is the complementary function. Now what is particular integral? 1 upon phi of d into the right hand side function. So here the phi of d is d square plus 1 and the right hand side function sin x sin of 2x. Now use the formulas we have discussed. So that is sin A sin B. Just now we have seen the formula. Sin A sin B is what?
Cos A minus B minus cos A
Cos
plus
of A minus B minus cos of A plus B. So here A is x and B is 2x. So cos of x minus 2x is minus x minus cos of 3x. Clear? But cos of minus theta is cos theta only. So minus sign will get merged here. So 1 upon d square plus 1 cos of x plus 1 upon d square plus 1 cos of 3x. So therefore, when we replace d square by minus a square, what is a here? A is, for the first case, a is 1 and for the second a is 3. Clear? So here we replace d square by minus 1. So when I replace, I'll get the case of failure, right? Case of failure. And here, when I replace, it will not the case of failure. But first is the case of failure. So when I replace d square by minus 1, as it is getting the case of failure, so what we do? We multiply by the independent variable, that is x times 1 upon phi dash. That is derivative of denominator. That is 2d cos 2x cos x plus 1 upon uh, minus 3 square, right? Minus a square. So minus 9 plus 1 cos 3x. Now, here 1 upon 2 times x by 2 I'm taking here Now here either you can multiply and divide by d, or you can directly operate this 1 upon d over cos x. 1 upon d means what?
Integration.
Integration, exactly. So 1 upon d means integration of cos x with respect to x minus 1 upon 8 cos 3x. So that is equals to 1 by 2 times x by 2, and integration of cos is sin x minus 1 by 8 times cos of 3x. Is this clear to everyone? Still, if any doubt is there, please ask. Oh, sorry. Here it is negative, no? Negative, no?
Yes.
Mistakenly, I have taken positive. I'm sorry. So it is negative here. So negative, negative, positive, positive. Please note this. Just so write the final solution, that is y is equal to cf plus pi. Y equal to complementary function plus particular integral. That is your final general solution, or the final complete solution. I hope the case is clear now. Second case, to get the particular integral by shortcut. If you still have any question in your mind, please ask. Any questions? Okay. If no questions, then let's have a short quiz.